Hello friends. In the lecture number 5, we want to study maxima and minima. One more very important applications of derivatives which we'll use to draw so many sketches and different field of engineering and other options. A very simple example from our daily life. Suppose Virat Kohli is on this crease and he hits a 6 to the stands. We want to calculate what is the total highest height of this particular 6 or the maximum length to this particular 6. One more example, suppose one soldier is here and enemy's fighter plane is moving with particular curve. The soldier wants that what will be the minimum distance where he will shoot the target so that the enemy's helicopter or the fighter plane may be destroyed. So these are the simple examples of maxima and minima. Suppose one curve fx equals to x square for all x belongs to real. Then the minimum value of this curve is at 0. But what about the maximum value? No maximum value because this curve is upward and no maximum value attains here. Similarly, one more, fx equals to mod x. For this mod x at 0, we are having minimum value. But what is the maximum value? No maximum value. But suppose we want to restrict from -2 to 1, by the way. These two curves we want to restrict from -2 to 1. Then -2, the highest height, and 1. From these two, which one is the maximum? What we'll say, at -2, the height is 4. Correct? And at 1, it is only 1. So which one is maximum? Then we can say the final result is at -2. Because the restriction, the closed bracket is given to you. Similarly here, if it is -2 to 1, what is -2? The highest peak value -2 modulus is only 2. And if it is 1, the answer is only 1. So depends upon in the question what restrictions given to you. If no restriction is given, for example in this one, then there is no maximum value. But the minimum value is 0. Hence, the first derivative test. What is the first derivative test of maxima and minima? First we start first derivative test and then the second derivative test. So what is first derivative test? Very simple. Suppose a curve is like this. And this point is, by the way, C. At this point, for this f dash x, same as in increasing and decreasing, at this any point f dash x is more than 0 because this function is increasing function, which we have already completed in the topic increasing and decreasing. At the particular instant, say C, this f dash c becomes 0. Why? Line is parallel to x-axis. And after that, f dash x is less than 0 because the function is downward and is decreasing function. So at particular point where increasing and stop and then decreasing. What is the peak point? That peak point is said to be point of local maxima. And what is the maximum value? Maximum value at C is whatever be the height, it is said to be the maximum value. Maxima point is different, maximum value is different. Maxima point means a particular point where we will get the highest answer. That highest answer of this function is equals to h. Secondly, by the way, the function is now decreasing. And at particular point, again by the way f dash d, this line parallel to x-axis. That is the lowest point. And now f dash x is again increasing. So this D point is said to be the point of minima. Why? Because the function is decreasing, decreasing, decreasing. नीचे जाते जा रहे, एक जगह जाके रुक गए, and then we start again up. So what is the least point? Least point is D. This D point is said to be point of minima. And what is the minimum value? At D, the depth, this is the minimum value of this function. Clear? How we understand the concept with any function? By the way, this value is suppose 1. C equals to 1. Then, in first derivative function, whatever be with us, substitute slight less. 1 से थोड़ा सा less. By the way, I'll put slight less. 1 minus h. And slight up. Say 1 plus h. For 1 minus h, if we substitute here, this f dash 1 minus h will be positive. Sign is positive. And when we put 1 plus h in f dash x, the sign will be changed to minus. So when plus sign changes to minus sign, that particular point is said to be point of maxima. Just opposite. When we substitute 1, suppose this point is 3. 3 minus h, a particular nearby point, 3 minus h and nearby point 3 plus h. If we substitute 3 minus h in f dash x, this sign comes negative. And when we put f3 plus h, the sign changes to plus. It means it is decreasing and then automatically start increasing. So this point D equals to 3 is said to be point of minima. But we are not using this method. Why? Because suppose the function is a very lengthy function, 3x square plus 4x plus 3 plus something like this. And we want to put the point 1 minus, say 1 minus 0.001. It will become 0.99. How we calculate 0.99 square? How we calculate 4 into 0.99? And if the powers are maybe x to power 6 or 7, then very difficult. 1 minus h and then 1 plus h one more time. It is very difficult. That's why we'll start with the second derivative test. So the important, what we are using in maxima, minima, maximum times in our syllabus, we'll use the second derivative test. First step, by the way, function is given to you y equals to fx. Second step, you have to calculate f dash x. Compare this f dash x. Third step, compare this f dash x with 0 and calculate the critical point same as in our increasing and decreasing. These are the 2 or 3 or 1, whatever be the critical points A, B, C. And then the fourth step, you have to calculate double derivative of the same function. And in this double derivative, you have to apply 1 by 1 A, then B, and then C. In the same function, you have to put the critical points 1 by 1. When you put suppose A in double derivative and you are getting a plus sign, no need to say that 230 hai, or 540 aa hai. No problem. We want, our consideration is only the sign. If sign comes positive, then the point is said to be minima. It means A is point of minima. But if you substitute B in f double dash x and you are getting minus, again I am saying, no need to calculate that it is 230 or 540 or 290 or minus 11 or plus 20, nothing. Our aim is to see the sign. Sign is important. So if it comes minus, the point is maxima. Correct? And if sometime we'll get 0, when we substitute the, by the way, point C and we are getting 0, it means the point of inflection. It means neither maxima nor minima. Sign is not changing as we compare with the first derivative test. So here, minima point is by the way A. then you have to substitute this point in the question. You will get minimum value of the function. When you substitute maxima point in the question, you are getting maximum value of the particular function. So no confusion between maxima and maximum value, minima and minimum value. Maxima and minima are the points, and maximum and minimum are the absolute values where we are getting, for example, Virat Kohli's 6th highest height, that is maximum and minimum values. But at which point on the ground it attains the maximum height, that particular point is said to be maxima. Now it is clear. Some problems from the exercise number 6.5. Some basic questions from 6.5. Then we'll start some geometrical questions in the next lecture. Say, first sum. Note down the first sum on exercise 6.5. fx equals to 2x minus 1 the whole square and plus 3. Find the maximum and minimum values, if any, for the following questions. Exercise 6.5. First question, and it is first part. See, this is a parabolic function. 2x minus 1 the whole square and plus 3. What will be its maximum value? 2x minus 1, or the minimum value of 2x minus 1. It is a parabolic function. Revise the concept, the sketch from class 11th. If we put 0 here, then it will become minus 1 the whole square, that is 1. Its minimum value, if we put half, this is the minimum, 0, and here it is 3. It means its minimum value of the whole function is 3, but there will be no maximum value. Why? Because this x, maybe you can put any number, you are getting maximum. There is no limit. But the minimum, there is a particular limit, because the minimum value of whole square positive is least value 0. And we are adding plus 3, that's why it is 0 plus 3. Now, second part of the same sum, 9x square plus 12x plus 2. We can make it a perfect square. See, fx equals to, we can write it 3x the whole square plus 2ab b square and plus 2 minus b square. 2, 3, 6. We need here 2 more. It means 2. This is a simple class 5th or 6th question. How to make perfect square. A square plus 2ab plus b square. What we have added? 2 square. Subtract 2 square. Balance equal. So the first one, these 3 will make 3x plus 2 the whole square. And minus 4 and plus 2 minus 2. That is fx. Clear? How we convert it into a perfect square. And the same thing again as the previous sum. The perfect square is here. It means its minimum value is 0. But 0 and minus 2 added. That's why minimum value of the whole function is minus 2. And what about the maximum value? Maximum value is a parabolic function, upward. So there will be no maximum value. Correct? One more. Third part. These are the simple questions where we are not using any derivative. Okay? fx equals to minus of x minus 1 whole square plus 10. Minus. Going down. It means minimum value is possible or not. We have to take. Going down, the curve is like this. There is no minimum value. But for the maximum value, 0 and 10. It means the highest value or the maximum value will be only 10. Why minimum value is not possible? You know this curve is going down. We can't say where it will. There were total no minimum value, but the maximum value it attains only 10. One more question for question number 2, some modulus functions and trigonometric functions. Second sum. First part. Say mod of x plus 2 minus 1 fx. You know the graph of mod x plus 2 from class 11th. Mod x plus 2, when you put minus 2 here, you are getting 0. Yes or no? When it is only mod x plus 2, then the graph is like this. Because minus 2 is the minimum value for this curve, otherwise it will go upward, there is no maximum value. When minus 1 is not here. But since minus 1 is here, it means its minus 1 is its minimum value. And what is the maximum value? We can't say what is the maximum value. Correct? So these are the questions, simple sketches. We are not using derivatives. It's the basic idea. What is maxima and what is minima? One more question of trigonometry. Third part. Hx equals to sine 2x plus 5. You know, sin x values lying between minus 1, 2 plus 1. Cos x value lying between minus 1, 2 plus 1. So, whatever be the theta, 2x or 3x or 4x, no problem. Its maximum value is 1 and its minimum value is minus 1. So, when maximum value of this one is 1, the total maximum value will be 6. And when the minimum value is minus 1, add 4. So minimum value of this function is 4 and maximum value of this function equals to 6. And the last question of trigonometry, one more. Say fourth part of the same question, second. Sine 4x plus 3. Sine 4x plus 3 is function fx. Now tell me, same as the previous one. Sine 4x. Sine 4x minimum value is minus 1. And minus 1 plus 3 mod, what we are getting? 2. So this is the minimum value. Now what is the maximum value? Maximum value of sine 4x is 1. And we are adding 3. So maximum value will be 4. So minimum value is 2 and maximum value is 4. Correct? So these type of questions. Now we start the questions based on second derivative. Say one question. Third part. Hx equals to sin x plus cos x and 0 less than x less than pi by 2. Open interval is given to you 0 to pi by 2. And we want to use here the second derivative test. So first we start with h dash x. It is cos x and it is sin x. For maxima and minima, the most important point is its derivative compared with 0. If it is not 0, no maxima and minima. As you know, the concept, we want f dash c must be 0. Otherwise, how the curve is increasing, at particular point we want f dash c 0 and then only it will be downward. That's why the basic condition of maxima minima is its first derivative must be 0. If its first derivative not 0, no maxima minima is possible. So h dash x compared with 0. Here we'll get tan x equals to 1 because cos x equal to sin x. And when tan x equals to 1, x equals to maybe pi by 4, maybe so many problems, so many thetas in complete 360 degree or and above. But what is the limit restrictions given to you? Between 0 to pi by 2. So 0 to pi by 2, we have only one critical point. Only one critical point. Now we have to test double derivative. So what is double derivative? Minus sin x and minus cos x. Now substitute x dash, substitute the value. What value? Critical point pi by 4. So put pi by 4. 1 by root 2, 1 by root 2, root 2 is LCM, minus 2, that is minus root 2. And what we completed in the theorem of second order derivative test. When the answer comes negative, no need to see root 2, 2 root 2, 5 root 2, no problem. Here it is minus. This minus shows that this point pi by 4 is the point of maxima. This pi by 4 point is point of maxima. Now I think you will understand each and every concept of second order derivative by this single question. Now one more algebraic question we will complete. Then we will start the next lecture for the geometrical problems. One more question. Say x minus 1 the whole square plus 3 and x belongs to, this time it is closed, and x minus 1 and it is fx. Sum number, fourth part of fifth question. How we solve when the closed intervals are given? First thing, you have to calculate f dash x, 2x minus 1 and plus 0, that is 2x minus 2 is the value of f dash x. It means when you compare this one with 0, we are getting x equals to 1. X equal to 1 is already here. Now we have to test only these 2 points because there is no value in between minus 3 and 1. No value. If some value comes between minus 3 and 1, we have to test that particular values, critical points. But since 1 is here, now we have to check fx and x. Simple table, and you will get the answer where we will get the maximum value. Put x equals to minus 3. Then put x equals to 1. So if you put minus 3 here, it will become minus 4. Minus 4 square is 16. 16 and 3, 19. Now put 1. You are getting 3. So what is maximum and what is minimum value? Maximum value is 19 at minus 3 and minimum value is 3 at 1. These are the two solution for this particular question, fx equals to x minus 1 whole square plus 3. One more question of the same group, that is closed interval group questions. Third part. Question is fx equals to 4x minus half x square where limits given to you minus 2 to 9 by 2. First we calculate f dash x. F dash x is 4 minus half into 2x. Means 4 minus x. For maxima and minima, the basic condition 4 minus x must be compared with the 0. Hence x equals to 4 is the critical point. Now you see that we have 3 options. What 3 options? You have to check all the 3 options, x and fx. 3 options, minus 2, 4 and 9 by 2. Because here the critical point comes from inside this closed interval. So you have to check these 3. First we start with minus 2. Rough column, put the values one by one in the function fx. So first f of minus 2. Put minus 2, minus 8, minus half and 4. It is 2, so minus 10. Secondly, put 4. What we are getting by substituting 4? 16 minus half and 16. So it will become 8. And now last 9 by 2. When we put 9 by 2, 4 into 9 by 2 minus half into 9 by 2 and 9 by 2. What we are getting? 2, 18 minus 81 by 8. Hence 8, 144 minus 81. That is 63 by 8. So what is the conclusion? out of this particular range, closed interval -2 to 9/2, it means you have to check these two, confirm, and whatever critical points we are getting in between this closed interval, we have to test. So what is the in between point is 4, so we have to test for 4. Out of these three, which one will give you the maximum? Maximum value is at 8. So maximum value is 8 and maxima is 4. So here we write this is maxima and this is maximum value. Maximum value. Minimum. Minimum value is -10. Minimum value is -10 from which point? Maxima -2. So minima is -2. This minima -2 will give you the minimum value of this function given to you. So whenever the closed intervals are there, we have to solve like this. No need to calculate double derivative or second derivative. But you have to form this table and then conclude simple. So this concludes our this lecture. Maxima and minima, first part. I think you are enjoying our maths classes. अगर अच्छी लग रही हैं तो गुरु दक्षिणा में लाइक तो मिलेगा. दोस्तों को बोलिए, वीडियो शेयर करिए और अगला लेक्चर आपको टाइम पे मिल जाए उसके लिए घंटी बजाते रहिए, सब्सक्राइब करिए, अपने फ्रेंड्स को बोलिए और पढ़ते रहिए, आगे बढ़ते रहिए. ऑल द बेस्ट.